You are reading this while sitting down. You are probably sitting for the hour before this. You will likely sit for most of the next several hours. At some point, you will move from one seated position to another. And at the end of the day, you will have covered, on average, if you are a typical adult in a high-income country, somewhere between 3 and 5 kilometers, possibly less. Ancient humans covered 8 to 15 kilometers daily on minimum days, and significantly more when pursuing game or relocating camp. The Hadza of Tanzania, one of the last groups living a traditional forager lifestyle, average around 11 kilometers of walking per day for women and 14 for men. Numbers consistent across multiple measurement studies. This is not exercise in the modern sense. They are not working out. They are simply doing what the day requires. And what that daily distance did to their brains, to the structure, the chemistry, the cognitive capacity of those brains is one of the most important and most consistently ignored findings in modern neuroscience. Because it turns out that the human brain was not built to think while sitting still. It was built to think while moving. And the sedentary life is not just making us physically unfit, it is making us cognitively different from what we were designed to be. The answer isn't one thing. There are layers here in hippocampal neurogenesis, in BDNF, in the specific relationship between walking gait and creative thought, and in what happens to a brain that stops receiving the movement signals it evolved to expect. Let's go. Start with the molecule that connects walking to brain function most directly. BDNF, brain-derived neurotrophic factor. BDNF is a protein produced in the brain and throughout the body in response to physical activity, particularly sustained aerobic activity at moderate intensity, exactly the intensity of long-distance walking. John Rady at Harvard Medical School, who spent years synthesizing the research on exercise and brain function in Spark, published in 2008, describes BDNF as Miracle-Gro for the brain, a molecule that promotes the growth and maintenance of neurons, strengthens synaptic connections, and supports the survival of existing neural tissue. BDNF levels are highest in the hippocampus, the brain region responsible for memory formation, spatial navigation, and emotional regulation. And BDNF production in the hippocampus is directly stimulated by aerobic exercise. Kirk Erickson at the University of Pittsburgh published a landmark randomized controlled trial in the Proceedings of the National Academy of Sciences in 2011, showing that older adults assigned to a walking program 40 minutes 3 times per week for 1 year showed a measurable increase in hippocampal volume of approximately 2%. The control group, doing only stretching, showed hippocampal volume decrease of the same magnitude. Walking did not just slow cognitive decline, it structurally grew the brain region most critical for memory and learning. Ancient humans, walking 15 kilometers every day, were providing this stimulus continuously, from childhood through adulthood, without interruption. Their hippocampi were being maintained and grown by the simple act of doing what the day required. Here's where it gets strange. The relationship between walking and thinking is not just chemical, it is mechanical. Walking at a natural human pace produces a specific rhythmic oscillation, a bilateral, cross-body movement pattern in which the left arm swings with the right leg and the right arm with the left that generates synchronous neural activity across the 2 hemispheres of the brain. This bilateral synchronization is associated with enhanced, creative, and associative thinking. Marilia Pezzo and Daniel Schwartz at Stanford University published research in the Journal of Experimental Psychology in 2014 showing that walking, specifically walking, not other forms of exercise, increased scores on divergent thinking tests by an average of 81% compared to sitting. The effect persisted for several minutes after the walk ended. The walkers did not just feel more creative. They measurably, testably produced more original ideas per unit of time than sitters. A Pezzo's proposed mechanism, the repetitive, low cognitive demand rhythm of walking frees prefrontal attention from the immediate environment and allows it to range more freely across associative networks, the neural wandering that underlies creative, connection making. The default mode network, the brain's associative, imaginative, self-referential network is most active during low-demand physical states, of which walking is the most natural human example. Ancient humans were not walking and thinking, despite the walking. The walking was producing the thinking. The 15 kilometers was not a cost of the forager life. It was the cognitive engine of it. Now, let's tackle neurogenesis, the growth of new neurons, because this is where the walking story becomes genuinely unsettling for anyone who spends most of their day seated. For most of the 20th century, neuroscience operated under the assumption that adult brains do not produce new neurons. You were born with a fixed number and spent your life losing them. This was overturned in the 1990s when Fred Gage at the Salk Institute and colleagues demonstrated adult hippocampal neurogenesis, the continuous production of new neurons in the hippocampal dentate gyrus throughout adult life. The critical finding for our purposes, the rate of adult neurogenesis, is directly regulated by physical activity. Running and sustained walking are among the most potent known stimulators of hippocampal neurogenesis in every mammalian species studied. Sedentary conditions suppress neurogenesis, not slow it, suppress it. Wendy Suzuki at New York University, who studies the relationship between exercise and hippocampal function, has documented across multiple studies that the hippocampal neurons most sensitive to activity-dependent regulation are precisely the ones involved in pattern separation, the cognitive function that allows you to distinguish similar memories, to notice novelty in familiar environments, to learn from new experience rather than assimilating it into existing categories. A brain receiving daily walking stimulus is continuously producing the new neurons most critical for continued learning. A brain that stops walking begins to lose that production rate. Ancient humans were not just smarter walkers. They were neurologically richer because they walked. Here's something else that almost never comes up. The specific terrain of ancient walking mattered cognitively in ways that flat pavement walking does not replicate. Walking on uneven natural terrain, the varied surface of a forager's daily range requires continuous, real-time proprioceptive adjustment. Every footfall on uneven ground requires the cerebellum and the motor cortex to compute a slightly different balance solution. Eyes scan ahead to assess surface. Weight shifts in real time. The ankle, knee, and hip joints process ground reaction forces that vary unpredictably from step to step. This continuous, low-level cognitive demand is completely absent in flat surface walking and entirely absent in seated activity. Sandra Afonso at the University of Porto and colleagues studying cognitive outcomes in natural terrain versus treadmill walking found that natural terrain walking produced significantly higher post-exercise executive function scores, the cognitive functions associated with planning, flexible thinking, and working memory than equivalent distance treadmill walking. The irregular terrain was not harder. It was more cognitively nutritive. Ancient humans navigating real landscapes were not just covering distance. They were continuously exercising the exact cognitive systems that modern neuroscience identifies as most critical for high-level human intelligence. So, here's the part nobody tells you. Herman Pontzer's metabolic research on the Hadza found something beyond the metabolic data that deserves its own attention. Hadza, adults in their 60s and 70s, show cognitive test scores, memory, executive function, spatial reasoning that significantly exceed age-matched Western adults in equivalent socioeconomic conditions. They have no access to cognitive training apps, no omega-3 supplements, no crossword puzzles. They have daily walking, varied terrain, socially complex group navigation, and the continuous cognitive demands of a forager existence. The cognitive aging gap between traditional forager populations and sedentary Western populations is large enough that researchers studying it have begun asking whether what we call normal cognitive aging in Western societies is actually accelerated cognitive aging driven by sedentary behavior, a departure from the baseline, not the baseline itself.